record this. I'll start recording. The first a couple of minutes, maybe for 10-15 minutes, we'll try to understand what is the intention of this particular DevOps Labs group. I mean, I think some of you are part of the WhatsApp group. If you are not, if you have directly joined from the meetup, you can actually contact me. And this is my email ID, right? So basically, Jagan at devops.org. Like I'll send out a mail. This is my slide which I prepared for the other startup which I run. So techtutor.org. However, I thought I don't want to use the same brand for this particular DevOps because I want a focused group only dealing with DevOps. So that's why this DevOps Labs has come up, right? So my email ID is going to be for anything related to DevOps. I can write it down here, devopslabs.org, right? So you can contact me for any consulting or if you want me to give a workshop in your company, or if you are looking for joining some meetups or anything related to DevOps that you would like to contribute also, you can feel free to drop a mail to Jagan at devopslabs.org, right? Okay. And I would like to understand from you guys before we start, what is your intention and what you expect out of this group?
So Jagan, this is Amar here.
Yeah.
Can you hear me?
Yes, I'm able to hear you.
So as I had posted on the WhatsApp group also, so I am mostly infra focused guy because I've been working 15 years into data center, cloud, and all that aspects. So now that the DevOps is picking up very fast, and there's a lot of requirement coming from the application side.
Yeah, now I'm recording this. Okay, so basically Docker is a application level application partitioning or software level partitioning. So Docker is a client server model, right? So basically the Docker version that I'm installed is 1.12. I'm using a Ubuntu 64-bit Ubuntu 1704 64-bit operating system. Docker is a 64-bit only technology, and as of today, it is a Linux only technology. Okay, so the version that I'm using is this, and this is Docker is a highly adapted technology. So it came just a couple of years back, and it is already used in pretty much all the cloud platforms, right? And it is also used in local environments. It's a lightweight virtualization. So hence you can install this in your laptop. It could be installed on Windows. It works on Mac or pretty much any operating system. But the only limitation that we have today is basically the host operating system, right? The host operating system could be Windows or anything, but the container you cannot have Windows or other operating system. You can have only Linux-based operating systems today. But there is a beta available wherein you can have container as Microsoft Windows also, but that is still not production ready. Okay, so as of today, Docker is a Linux only technology. So when you install Docker on Windows, you have a Docker version called a Docker for Windows, and whereas when you install Docker on Mac, you're going to install something called as Docker for Mac. And if you want to know more details about it, basically you can go to this docker.io, right? So there you can see this, and Docker is available in two variant. Basically, one is the open source version, and the other one is the enterprise version. So you can for commercial activity you can use the enterprise Docker enterprise edition, and then for free testing purpose and startup for learning purpose you can use the community edition, right? Okay, so I am using community editions free version here. Okay, so basically in order to list the images that are present in the local machine, you can issue this command called docker images, right? So basically the Docker images is listing all the images that are present in my local Docker registry. So basically Docker has this concept called Docker registry. So the Docker registry will hold up all your images that are present on the local machine. In fact, you can also set up private registry or a central registry in your company wide, right? So basically, you may have a Docker registry that is hosted in some server on your company network, wherein people can push images or pull images from there, right? So basically, that's the way it works. But as of now, I'm using a default local Docker registry. So this is how it works, and these are the operating systems that you operating system images that you have. Okay, so but the beauty or the interesting part about these OS, if you see, this CentOS is, I mean, basically, as I said, it is all 64-bit variants. All the operating systems that you are seeing here, all are 64-bit variants. Look at the size of the CentOS image, right? It is just 190 MB, right? And whereas if you take Ubuntu 1704 64-bit operating system, it is just 91 MB. Whereas if you compare the same with a VM image or an ISO image, minimum it would be of 1 GB size. If you download Ubuntu 1604 32-bit, maybe like it would be around 800 900 MB, and if it is 64-bit, minimum it would be of 1 GB size. Whereas here the Docker images are basically smaller in footprint. Basically, the reason for that is, let me see if I can open up the whiteboard. Okay, so the way it differs is basically, if I take, sorry, there is some problem. Okay, so I'll take this particular this one. Assume that this is VMware. Okay, here you have your hardware here, right? So on top of hardware, you're going to have host OS, right? On top of the host OS, you are going to use hypervisor, right? So the hypervisors could be your VMware. Hypervisor is a general term, as you all know. VMware, it could be vSphere. However, in case of vSphere, vSphere is like, I mean, it doesn't require any host OS. It is a bare metal hypervisor, right? So bare metal in the sense I can directly install on the hardware. I don't need a host OS. But however, how this vSphere works is it will have its own thin OS. So nothing is going to work without OS. So anyway, the OS is part of the vSphere. Otherwise, if you install VMware Player or like VMware Workstation, all that, basically you're going to install on top of the host OS. Then you're going to have the containers over here, or I mean, we don't call it as containers. We call in VMware, you know that these are called as virtual machines or the VMs. These are the virtual machines, right? Okay. Now, let's say if we take, okay, let's take the Docker. So assuming you're going to take the same hardware configuration, so the hardware is going to be here like this. You're going to have host OS. You're going to have the host OS. On top of this, just like hypervisor, you're going to have Docker machine or Docker engine, right? Let me call it as Docker engine. Okay. Now here on top of this, just like we had VMs, VM instances running on top of the hypervisors, here you're going to have containers, right? All these are actually Docker containers. These are containers, and each and every container, this one could be Ubuntu, whereas this one could be SUSE operating system. This one could be Red Hat. This one could be CentOS, and so on. But what is the real benefit of going for VMware versus this one? See, however, though I'm just comparing VMware with, Docker. Docker is not a replacement for VMware or anything. It is just going to complement. But let us understand the technical difference. The technical difference is basically on the same hardware, on the same server. Here, if I could support, let's say, 50 VM machines, right, virtual machines, it is easily possible that I can go up to like 500 to 1000 containers on the same hardware. So that is the real benefit of using Docker. So this is a Docker based this one. This is your Docker, right? So over here, technically speaking, all these containers are going to run on the kernel of your underlying host OS. That is why I said this is a Linux only technology, because the Linux kernel supports something called as LXC, right? It supports something called as LXC. So the lightweight container ship, this one. So basically, unless the underlying operating system, unless the kernel, Linux kernel supports, the LXC, Docker is not going to work. So basically, you cannot install, Docker on a very old Linux operating system, right? So starting from 3 some version onwards, actually they all support this LXC, right? So using LXC, Docker is able to support this kind of virtualization. So just like VMware isolates all these operating systems, Docker engine also isolates all these operating systems. Though these are like, they mimic like an operating system, technically speaking, they are not full-blown operating system like VMware, right? These are basically all the operating system services are supplied by the underlying host OS. So technically, all these containers live in the kernel of the host OS. But since Unix operating system or Linux operating system in general is capable of handling multiple users simultaneously, it is a multitasking operating system, multi-user operating system. So this is like, I would compare these containers just like a heavyweight process. They are like heavyweight process, right? The only difference is why I call this as heavyweight processes. They are slightly they support more than your typical process, right? So each and every container will have its own IP, just like any other operating system that is there in the VMware, right? So every container will support its own IP, and for the application that runs within the container, it is going to look similar to, it is not even going to come to know, it's going to know that, okay, this is running inside a container, which means that is a big advantage, right? You don't have to develop your application specially catered for a container. You can write your application just like the way you have been writing. The same application, if it runs on VMware, it is also going to run within the container, right? So, but the application which runs within the container is going to require some operating system services. Those operating system services are essentially supported or supplied by the kernel that is part of your host OS. So the beauty or the interesting point is, this host OS could be a Ubuntu OS, whereas the container could be Red Hat. This could be CentOS. This could be some other operating system, right? The point is, all these have to be some kind of Linux operating system. So because the way these operating system, these containers differ is, they are just different distributions of the same Linux operating system, right? So that's where the Docker comes in handy, right? So basically, it shares the file system. All that is basically, it's going to share. It's going to be stored under the host OS, and any differences between these things, like for instance, you have modified certain files. So basically, the Docker supports some kind of version controlled file system. they use a sophisticated file system called AUFS, right? So using those things, basically it manages in a magical way that with small footprint, it is able to support, or it is mimicking like a full-blown operating system. But I cannot really compare these containers with a typical VM machine. But the advantage is the footprint is small, which means on the same machine, now I'm able to support 500 or 1000 containers versus 50 containers, which means now the utilization of the hardware is much better. It has improved phenomenally in case of Docker. So today it is possible that the laptop that I'm using, within that I'm using a Mac laptop. Within Mac, I have installed Ubuntu 1704 operating system, and I have just allocated one core to this. But easily within this one core, I can go up to 100 containers, 100 Docker containers. Whereas this is not possible with VMware or a heavyweight virtualization technology. So that is one big benefit of your Docker, right?
And Jagan, Ashi this side. So each container will contain how many applications? Like for example, one container will have one image of that application, or how many?
So basically, image is going to be one, right? You may have different images. For instance, I have let's say Ubuntu 1604 64-bit Docker image, right? I have a Docker image which has, okay, so Docker image plus maybe Java plus maybe Maven plus it's going to have my application, right? So typically you have to have one application per container. So when I prepare image, Docker image with all this, now I can create, out of this I can create hundreds of Docker containers, right? With one image, just like you create one VMware image and then you can deploy hundreds of VM instances out of that. Same way you can create Ubuntu based image or CentOS or any kind of operating system image, and you may go up to 100 or 200 depending on the hardware capacity. Now it is possible that it is not necessary that everything must be of the same image type. It is possible that in this case, the way I have demonstrated here, this could be a CentOS image, right? CentOS Docker container, which means, of course, the image is based on some CentOS operating system. This image is some kind of Red Hat Docker image. This is SUSE image, and so on, right? So with one image, I can spin off any number of containers. To answer your question, basically the number of applications that can run in one container, ideally one container, one application. But technically it is possible that you may have more applications, but the real benefit of Docker you will be able to exploit, you will be able to utilize completely if you have one Docker, one application. That is why Docker is a very suitable a model when you go for this microservices kind of architecture. But even otherwise, I may have a huge monolithic application which I can prepare as a Docker image and I can actually run it. It will work, right? As long as your underlying operating system is capable, underlying hardware is capable of running, it will work. But the thing is, am I really using Docker effectively? No, I'm not using effectively, because it is going to behave just like your VMware, right? It is not lightweight, because if I take a huge application which is 10 GB and which has a lot of complex services and things like that, basically I'm going to install all the unnecessary, or like all the services that typical operating system is going to have. Today, the way the container has, what would be there in a container is, let's say I have a simple report application. If this report application, assume that this doesn't require network services, you are not going to install network services in that container as part of that image, which means you're going to remove this. If you don't need ping, you're not going to install any of the network related stuffs, right? If you don't need proxy, if you don't need email server, if you don't need unnecessary services, you're not going to install them. Whereas if I take a VMware image, if suppose this is a Ubuntu based image, whether I like it or not, all the services are already there bundled in the Ubuntu operating system. Unless I go and prepare a custom image, or I go and uninstall those things. Typically, all the OS services are going to be running in the Ubuntu because it is a full-blown operating system. Whereas if I take a container, only the required services are going to be there. But if I take a monolithic application, huge application, and then fit inside a container, literally I'm replicating whatever the VMware is doing. I'm doing the same thing in Docker. In that sense, you're not going to see any benefit, performance benefit, or any kind of benefit that you typically expect in a Docker. Because in Docker, you're supposed to be having small services, small applications running inside, right? So if you have a huge application, break that application into small microservices and host it as a Docker container. That is how it works actually, right?
So,
Jagan, one
Jagan,
question from my
one
side.
Docker. Yeah, please go on.
Hi Jagan, Mayan this side.
Yeah.
The size of the image is less only because all the operating system is lie inside the kernel, right? So all the functionality which is like in VMware, we are actually installing the Ubuntu or any operating system image, so we have to install the kernel part also. So here all the kernel services, all the kernel and all the memory management and all the things are related to operating system were already installed in kernel mode. So that's why our operating system is lightweighted, right?
Exactly. So everything else is supported by the basically the previous.
Host
Your
operating system.
underlying. Yes. Yeah.
Yeah, and
Underlying
one more
OS is
thing,
going to support.
yeah, one more thing. So all the all that images is heavyweight processes, right? So in case of they will share the same hard disk and same kind of processor, right? So
Right.
we have to configure as per our container.
Actually, yeah.
Like
So though you have those facilities, typically unlike your VMware, you are not going to really allocate one CPU per container and so on. It is managed by Docker, right? The Docker engine is going to manage all that. However, you have some advanced configurations which you can use to allocate, like I need so much of RAM for this, or I need so much of, sorry for the background noise, actually I will close the door. One second please. Back. Okay, so basically yeah, what we were discussing.
we are discussing about that how that Docker image size and hard disk is connected and processor is connected.
Right. So basically, you are going to let Docker manage about the hardware stuffs. But however, if you wanted to say that I need, for this particular container, I need so much RAM, so much of CPUs and so on, it is possible. You do have such, configurations or provisions in Docker. But typically, you are not going to do that. You are going to let Docker engine handle all that for you, right? But however, if you want, it is possible.
Okay.
Yeah.
Okay, just like they are just like a process, so that will
Exactly.
be managed by host operating system itself,
Exactly.
right?
So in
And
case, yeah, please go on. Please.
because of this limitation, that all the containers is lie inside the host operating system, because of that, we are not able to create any kind of Windows kind of Docker, right?
Yes, exactly. Because as of now, it is supported by Linux kernel, right? The underlying host operating system has to be a Linux operating system. In case your host operating system happens to be Windows, right? If this is Windows or Mac, then this is not Linux. So what you're going to do when you install the Docker for Windows or Docker for Mac, right? So that is going to come up with a thin Linux OS on top of it. So it's going to install a thin Linux OS on top of Windows, or on top of Macintosh. That is how Docker is supported on Mac or on Windows. But like you rightly pointed, so what is not possible today is I cannot have a Windows as a container. But however, I can install Docker on Windows and I can install Docker on Mac. That is possible, but I cannot have a Windows container on top of Docker engine, because it is today it is restricted only to Linux, because the underlying kernel has to be Linux, which is not with the Linux kernel. Linux kernel cannot support Windows operating system, right? Because the OS services are still supported by the Linux kernel, which is there in your host OS. That is why Windows is not supported as a container today. But however, there is a beta available today. Microsoft is working on Docker support. So maybe it is possible that a few months down the line, right, it is possible that Docker may natively it may support. However, we are not sure how they are supporting it, right? They may have, like for Linux based operating system, they may use the Linux kernel, but similar operating system support, services may come from Microsoft. So by which Docker or Microsoft may come up with Docker-like stuffs which will support similar, application level or software level virtualization, right? But there is
currently it's not available, but yes, it will be come soon, right?
Yes, exactly. Beta is already available.
Okay. And one more thing, how can we where we can find that Ubuntu, like
Okay.
you wrote Ubuntu 16.04 64-bit Docker image. So that is the image, just like the operating system which we find that ISO files and
right. So basically,
internet, right?
all the images you can go to hub.docker.com, right? Hub.docker.com. If you go here, all the predefined images are already available. If you do a explore, you can see that MySQL. Even the companies, the way they are shipping their softwares are changing because of Docker. Look at this. This official Ubuntu image, right? Official Ubuntu image is available as a Docker image now. And if you want Redis, you want Nginx, so you don't have to install softwares these days. It's all it comes pre-configured. If I want MySQL, it is pretty easy, right? Just you have to go to your command prompt. Let me show you. However, it may take some time depending on how big is the image. Let me give you some idea. I think we'll not be able to conclude the session by 11:30. Hope you guys don't mind. We'll go. Can we extend till 12 if you don't mind?
Yes, sure.
Okay, cool. Okay, so we saw Docker images, right? So same way you have this command called Docker PS. So using Docker PS, when you issue this command, yeah, please.
Yeah, Jagan, Amar here.
Yeah.
Yeah, Jagan, actually, what I have got an update that Windows Server 2016,
Yeah.
which is currently being launched by Microsoft, that has some kind of Docker support. So I really haven't explored what kind of Docker
Yeah, that's
support,
what.
but
So
they
I
say
have
they
seen the
support
beta.
container.
Yeah, I have seen the beta.
Yeah, okay.
But what I understand is it is still not ready for production. Actually, production level. It's in
Okay,
beta level. Yeah. But yeah, like I said, maybe it is possible that in 6 months down the line you'll have Docker supported on Windows also. It's possible. Yeah.
Yes. Right. Okay. Thanks.
Hi.
Yeah.
Hi, this is Lohit. So what we know is that since I work on Windows extensively, so we have a Docker support for Windows 10. That is nothing but Windows 2016 in the server level. So we can install a Docker engine on Windows because it's equal to 2017.
Installing
that
Docker
works on the Docker.
Yes. The installing Docker on Windows is allowed, right? That is supported.
Right.
But what we are talking about is having container as Windows.
As Windows, yeah, that is still not available. Correct.
Right, that is still not available. That is what we are discussing. Right. So basically, like you said, installing Docker on Windows and installing Docker on Macintosh is allowed. But the point is, how they are allowed is, it will install a thin Linux OS on top of Windows or on top of Mac. That is how it is supported. Correct? Right. But what the beta that we are talking about is basically container itself is possible. I mean, that will come moving forward.
Image.
Yes.
The Docker image.
Yeah, you can even download Windows images. Maybe like if you want the Windows XP, as a container, it will come in future. That's what I'm saying. So that is there in beta stage now. Okay.
Okay.
Yeah. So you have this
So,
document.
Jagan,
Yeah, please.
Jagan, one quick question on Docker. So let's say I have a development environment and I have a testing environment. Both the two are different infrastructures.
Right.
And I need to basically use Docker to get my deployment and all done from in one of the microservice I take, and I want to deploy it on my dev environment and then to QA environment.
Okay.
So can you let us do a process flow that how we will go ahead for that?
Yeah, it is pretty simple, right? So for instance, yeah, so let us, I mean, maybe like what I'll do is I'll first explain the basic Docker commands, then I'll give you a, I mean, overall idea how you can achieve this particular thing, right? So what I'll do is I'll just continue. Docker images basically will list all the Docker images, and Docker PS will basically list all the containers that are running on top of your Docker engine. Okay, so as of now, so many containers are running on my system, right? So basically what you see, this one is the container ID. Every container, container is equivalent to VM instance, right? Every container is allotted a particular unique container ID. And this particular image is my own custom image. I also contribute to Docker. You can see some of my Decutor, images available in, Docker Hub. Okay. However, this is my local one, right? So basically, this particular container is based on Decutor Ansible CentOS image, and this is the startup application that runs when you run the container. Okay, and then this says when was this particular image created, right? And like how long this machine has been up, and so on, right? And this shows you some of the port mapping and so on, right? So basically here this one shows, if you see this one, it says that 7000 port 7000 on the host OS is forwarded as port 22 inside the container, which means like basically this particular I have created a container for Ansible, and Ansible expects a SSH server to be running on the container. So basically I have installed SSH server on this particular image, which is a Ubuntu based image, and SSH server requires this port default port 22. So this port 22 is mapped to 7000 port on the host machine. So the 7000 that you are seeing is on the host machine. This 22 that you are seeing is on inside the container level. So if you want to have multiple containers all using port 22, this is how you do it. So the port 6000 is mapped to port 22 inside this particular container. So now I'm able to have 6 containers all using port 22, but technically speaking, they are not really using port 22. For the OpenSSH server that is running inside the container, it believes that it has got its own port 22. However, technically it is using port 7000 on the host machine. So this particular container is using port 6000 on the host machine. This is using 5000 on the host machine, and so on, right? This is how it works. And basically, you can optionally assign a independent name for, individual name for every container. So for instance, some question was asked that, is it possible to have a QA machine, and is it possible to have a development machine? One second. Yeah, I'm back. Yeah. So you can actually name these containers. You can assign that dev1, dev2, dev3, qa1, qa2, qa3, those kind of. You can assign individual names, which you will be able to differentiate as QA server 1, QA server 2, QA server 3, and development server 1, 2, and so on. And if you want similarly production server, production 1, production 2, production 3, and so on, you can actually give different names for these containers. Okay, so now let me show you how this containers behave, right? So basically, let me do a Docker inspect and give this particular container name, right? If I issue this particular command, this command is going to give me a lot of details about that particular container, that is that particular VM, virtual machine, right? So what is the current state of that machine, right? And basically it is also going to give you the IP details, the network details. You can actually, let me scroll. So there are quite a lot of details which we'll not be able to go through each one of them as of now. However, these are the important stuffs or the common stuffs that are typically we all care about, right? So basically you can see the network settings here, right? And you can also see below that, you can see that this has got, it is configured to use this particular gateway, and this is the IP address of this particular container. So 172.1.7.0.7, that is the IP address allocated to this particular container, which means I would be able to do a ping 172.1.7.0.7 just like any other machine, right? Whereas if I do a if config for this particular machine, okay, so I think I've not installed the network tool, so hence I don't have this one. But however, the IP address of this machine is different, and the IP address of the containers, each and every container is going to be different. Okay, let me do a Docker PS again. Okay, now if you wanted to get this IP address alone, so you could do a Docker inspect the container ID like this, and you can say grep IP address, right? So this way you should be able to get the IP address. Now let me do a SSH to this machine, right? So this is going to be a CentOS. I have created a user called root inside that this one. So hence I'm going to log into this machine with this IP. Okay. So look at this. The way it works. It is nothing different from whether no one will be able to really identify whether this machine was prepared using VMware or it is working based on Docker, right? So if I just give you the IP address, you will not even be able to differentiate that, right? And this is inside. We are inside the container now, right? You are inside the container, and if you typically give the host name is typically they take the Docker assigns the Docker container ID itself as the host name. However, it can be modified. Okay, so I'm outside the I've come out of that container shell. Okay, so far any questions? So now we learned how to list the images, how to list the process, and probably if you want to just let me pull, we don't have MongoDB, right? So if I wanted to get MongoDB, so the way you can get that is basically you can say run Mongo, or just if you say pull Mongo is basically is going to check whether this particular image is available locally. If not, it's going to go and pull the image from the hub.docker.com, right? So basically, I think not configured the internet or something, so it says that tag not found. Okay, let me see if I have Mongo here. Yeah, Mongo is here available. If you click on this, you can find the details about this container and the way you can get it, right? So Docker pull Mongo should work ideally. I think I've not configured internet on this particular this one, so it's not able to pull it. Okay, otherwise by default it will be able to get it. So let me see. I'll show you how you can launch or how you can stop the containers. I can stop a container using this Docker stop and followed by the container ID. So this will basically shut down, kind of, right? Stop is equivalent to shutdown, right? So now if I say Docker PS, now there is one less container. You can also give multiple container IDs, space separated, right? Or you can also give one of the name of the container. So basically that also should work, right? So now it has stopped all these containers. Now we should have only a couple of containers. You can also stop at one shot, right? So you can also say stop using this command ps -aq. you can also do that. So let me show you what this ps minus aq will do. Docker ps minus aq, basically it will just list all the container IDs. When you club with A, it is going to show all the containers, irrespective of whether they are running or not. See, for instance, if I say AQ, now it shows a big list. Whereas if I say Docker PS Q, it only shows the running containers. These are the containers which are at present running, right? But whereas we are seeing lot more containers which are in the exited state. So you can do a Docker PS minus A. So this shows many containers. So those are the container IDs you are seeing. So if you wanted to stop all of them,
Hi Jagan.
yeah, please.
Yeah, if I want to stop Docker service itself, right?
Yeah.
Otherwise, it keeps running all the time. So how do I stop Docker service?
Okay, you can say just sudo service docker stop, right? So if I say
Got it.
docker ps, now it's not. I think it has stopped. It's restarted. Okay. Sudo service docker ps. Okay, sorry, docker stop. Let me check if I'm running docker as 1 second. Yeah. So why this is running is basically I have launched Docker enabling remote API facility here. So basically, unless I stop this, I'll still see this. I have manually launched it, so I'm going to stop the Docker this way. So otherwise, if your Docker is running as a server, right, as a daemon, you should be able to say this particular command. Docker service docker stop. As of now, the service is not running. So if I say docker ps now, you'll get this kind of command because now this docker is stopped. In order to start it, I can say docker start, right? So this will start as a service now. Now if I issue this command, now it shows up again, right? Docker minus p a, yeah, it shows all the containers and these containers are exited, right? All the containers were exited. So if I wanted to clean up this, so basically if I wanted to remove these containers, so what I could do is I have this command called rm, right? Rm, the same way, just like you stopped, you can also give the containers independently, right? You can give one by one, or you can also use this command, handy command rm $docker ps minus aq. Why why you should be using minus aq is basically irrespective of the state of the machine, you wanted to list all the container IDs, right? So for instance, none of these containers are running at present, all these are exited. Basically what rm will do is, unlike stop, rm will remove those containers. It is going to delete those docker containers, right? So the use of why you need to delete is basically if you suppose some of these containers have used as taken up port 7000, 6000, 5000, unless you remove those containers, those ports are not available for other softwares to use. Hence, you may want to throw away or you may want to terminate those containers once you are done, right? So in fact, it is similar. It works almost like same as your AWS, right? So in AWS, what you do is you spin off a VM. Once you are done with that VM, you're going to terminate it, right? So as long as you keep them, even if you stop those VMs, it is still being billed for, right? They're going to charge your card, because whether you're running those VMs or those VMs are in the stopped state, irrespective of that, they're going to bill you. So once you are done with something in cloud, typically the recommended practice is that you are going to terminate those instances. The same is applicable for Docker as well. The only thing is Docker can run on AWS or Google platform or locally also. In this case, we are using Docker locally, right? So hence it is a good practice to clean up the containers once you are done, right? So now after this, if I say docker ps minus aq, now no containers are running, right? Okay, so this is how it works. Okay, now, okay, not this.
Jagan, can we restart this exit state machine?
Yes, you can. But as of now, I have removed them, right? So for instance, let me launch some now. Okay. So I have these images, right? Let me run one of the Ansible, image. So let me say -d. I'm going to launch this particular thing with, let's say, port 2000, which I'm going to map port 2000 on the host machine. I'm going to map it as 22 inside the container, and I'm going to give the container name here. Okay, I'm going to give the image name, right? So I'm going to create a container out of this particular image, right? Now, also, if you're going to use this image to host some web servers and things like that, you may wanted to expose the port 80. Otherwise, you will not be able to, access the websites that is hosted inside the container. So in this case, I'm using this particular Ansible CentOS image that I have created to host some web pages and so on, right? So I have installed Nginx web server inside the host. Hence, what I'm going to do, I'm going to map 2500 port on the host machine as port 80 inside the container. And this port 80 inside the container will be used by the Nginx web server. Okay, so let me explain what are these. This one, basically Docker, like I said, it is a client server model, and Docker is a client. Okay, I'm hearing some background noise. If you don't mind, if you can mute, it will help. Yeah, thank you. Okay, so Docker is a this particular tool that we are using. This is a client tool, and whereas the Docker is as of now running as a service, right? So as a daemon. Okay. Now, when I issue this command, Docker client is going to request to create a particular spin-off Docker container out of this particular image with these port mapping. And this particular -d indicates you wanted to launch this particular container in a background mode. In the sense, it is not going to take up this particular terminal. Otherwise, there are other options like you can say that -it, right? -it, when you issue this command -it, it is it is possible that you can say that I wanted to, once this container is launched, I may wanted to get a particular shell, right? So I wanted to get inside the shell of the container so that I can do some administrative activities inside that. However, in this case, I would like to launch the container in a detached mode, right? So -d stands for detached mode or in the background mode. Okay. So now when I issue this command, it gives this long number. Basically, this is the Docker container ID, right? So basically, if I say Docker PS, now you can see this particular container ID and this one matches, right? This is a short form of the container ID, and this is the full blown container ID, right? However, you can also use the first 3-4 letters as long as they are unique. Okay, now we have started the we have booted this machine, and this is running, right? So if I wanted to check, let's say, let me see what is the IP address of this machine, inspect, right? So you can also give this container, and there is yet another yet another commands like, you can say -f if you wanted to just see the network IP address, right? Network settings dot IP address. You can also do like this. So you should be able to get the IP address of this. Now, if I wanted to check if any websites are running inside, I can say 172, right? Okay, so as of now, it says, looks like the Nginx server is not installed on this, right? So this is where you can either use Docker itself to perform the configuration management on it, right? You can install softwares on it, on this container, or you can use Ansible or Puppet or Chef, any one of these automation languages to configure this machine. As of now, the way we are using Docker is just as a provisioner, right? Just like VMware, right? Okay.
Jagan, what do you think that in gateway type or data gateway or payment gateway type of, especially in data gateway type of application, we have to configure all the port mapping thing which you are provided earlier in run command?
Yeah, so this port mapping is basically, let me show you how this works. Okay, I don't have, okay, I have this, okay, I have a Docker file here. Okay, so let me open this Docker file. So this is how you're going to prepare an image in Docker. If you wanted to create your own custom image, basically this is how you're going to write. So this is the infrastructure as code. Someone was requesting in the DevOps our WhatsApp group. In fact, actually in this group, as I believe, people come. I think some have directly joined from Meetup, and some people have joined based on the WhatsApp. This one. If you're not sure if you're not heard about the WhatsApp group, let me give the WhatsApp group here. One second. Or anyway, I'll just leave that in the basically the. I think I don't have that URL here. I have it here, however, right? Yeah. So this is our this one. Okay, the URL I'm talking about is not sure actually. What's this?
Jagan,
Yeah,
I will share on the chat.
yeah, sure. Yeah, thank you. That'll help. Okay, so basically, in case you're not part of the WhatsApp group, maybe you can actually no, but if you share in the WhatsApp, okay, you are going to put it in the WhatsApp, is it? But okay, basically, I would like to post it in the. Okay, can you put
No,
it in
I
the
will.
meetup in our this particular session chat? Can you put that if you don't mind? Go to meeting.
Yeah, in the end, yes, I will put the both the chat and this also.
Okay, yeah,
Okay, so
thank you.
this
Yeah, so it will appear here, so we can proceed. Thanks for that. Okay, so basically here, this particular Docker image, what I'm trying to do here is basically every Docker image is prepared based on some base image, right? So it is based on some base image. We'll wrap it up by 12:15. Okay, this is based on a base image called Ubuntu 16.04, and this particular image is available in docker.hub.docker.com. And here, if you have any kind of proxies, you can actually use those proxies here, right? Let's say 10.20 30. We'll take a hypothetical port. This is like some 40, and let's say this is the proxy IP. So you can actually give this proxy as your. I mean, if you in case you're using, your company is using proxy, you can actually export those proxies here. And this is the way you typically install softwares within the image, right? You are preparing the image like this. So this is the same command that you type, you use to install softwares within the Ubuntu terminal, right? So the same commands can be used here. The only difference is basically you're going to supply the command after the run command here. So basically from env run, all these are basically your Docker commands. Okay, so this is how you typically prepare your image. Coming to your question, right? So you are asking like, should I expose those ports? If you look at this particular image, what is the purpose of this image? This image is going to host a SSH server. And what is the default port the SSH server will use? Port 22. Hence, what I should do, I should expose the port 22, right, within the image. If I don't do so, what would happen? no one will be able to connect to that machine with SSH. Correct? The other purpose I would like to, the other way I would like to use this particular, images, I would like to host some, website. Maybe I may install, Nginx or like Apache or WebLogic, those kind of app servers or web servers. In that case, they are going to require port 80 for supporting HTTP, right? So basically websites. So I'm also exposing port 80. So to answer your question, if your software requires some specific ports to be exported or exposed, then you are going to decide that, right? How otherwise it's not mandatory that you should be doing any kind of port mapping. Got it? It depends on
Yeah. Yes.
your image and your requirement, right? Otherwise, by default, no ports will be exposed by Docker unless you explicitly use these kind of ports, right?
And we can spin our container using this code, right?
In fact, yeah, you can. Yes, this is the exact ports I'm actually using to forward. If you look at this, okay, let me minimize this here. If I do a Docker PS, you can see that the port 22 which I exposed inside the container Docker file, that is what I'm mapping with host port 2000, right? And because our container exposes a port 80, the same I'm forwarding to port 2500 on the host machine, right? It totally depends on your image and requirement.
Okay, Jagan, one question which I want to ask, that in run command it is mandatory to provide the mapping of these port.
Yes, exactly.
Like you are so in case it's a large, if it is a data gateway, so we have DNS port, we have HTTP port, we have proxy ports, and we have TCP ports. So there is a whole lot of ports is there, right? So in case of in run command, we always have to manage by ourselves that this application port is mapped to this. In case of multiple container also.
Yeah. So if you are going to see, typically the way you use any of these automation tools is basically for provisioning, for orchestration, right, and configuration management.
Right.
So for orchestration, Docker has its own native technology called the Docker Swarm and Docker Compose, right? You can write a Docker Compose script wherein you can supply all the port mapping, all that. It is not mandatory that you should provide the ports in the run command. But our run command is a quick and easy way to launch a container with some specific ports. But like you said, if it is going to be a very complex one, you may write all that as a Docker Compose script.
Okay.
Right. So there you don't have to supply all this, because it is not practically possible that if you have like 10 different port configurations, it might be difficult for you to export every single ports that way, right? So that's where Docker Compose is used. Docker Swarm is basically a way you can create cluster of Docker containers, right? That's those things are typically used for orchestrations, right? So orchestration is like, I have my product, HRMS product. This HRMS product, if I would like to host on different containers, maybe my HRMS product requires WebLogic server. Then I will have one container which will have WebLogic server, wherein I will host my HRMS product. But my HRMS product might require MySQL as a database. So for which I may have yet another container, which will have MySQL and all the database stuffs will be available on that container. So when you will use typically Docker Swarm and Composes, basically, if you would like to start those containers in some specific sequence, right? First, I would like to start the database server. Then I wanted to start the WebLogic server and so on. Some sequence will be there, right? So in such cases, typically you go for whenever you're managing more than one container, which is collectively used by one single application, that's when you normally go for Swarm and Compose. But however, Docker is just one solution that you have, right? You can do the same thing. You can use Docker as just a VM virtualization technology, and you can go and use probably Ansible or Chef or Puppet or any of these, or SaltStack, those kind of automation languages. Ideally, I would say you can use Docker for virtualization, like we created this machine. Once you have spinned up this machine with Docker, probably you can actually do the orchestration and things like the other stuffs, because if you are looking for load balancing, monitoring, those kind of services, though Docker Swarm supports those things, but in the enterprise level, if you are going to, if you require hi-fi features or like scaling up, scaling down to in a very bigger level, right? In a smaller level, of course, Docker Swarm supports those things. But if you are looking for a full-blown enterprise class solution, probably you should consider using Kubernetes, those kind of softwares, right? Kubernetes is coming from Google, which you can use to scale up. Like, let's say if you're going to manage 10,000 nodes, 50,000 nodes, or 1 lakh nodes, and they may have to scale up and down, and like even if one WebLogic server goes down, automatically the Kubernetes has to start some start up that, so that like you have a fail safe 24/7, like you cannot tolerate the downtime. So then you may have to consider using Kubernetes, those kind of software, right? Okay, so I think, yeah, so for the, we can probably, like I would say, I would stop here, and if you have any questions, we can take up the questions for the next 5 minutes. By 12:15 we'll close it, because I think like I'm okay, but I think like I don't want to torture other people, right? It is Sunday, and I don't want to take up too much of your time. So the next 5 minutes you can ask some questions and we'll wrap it up. I'll upload this video in YouTube, and I'll share the URL probably in the same meetup page. And for the folks who are in WhatsApp group, I will share the URL in WhatsApp group. Yeah, so you can ask the questions if you have any.
Yeah, Jagan, this is Amar here.
Yeah, Amar.
So Jagan, as was my current understanding, that a DevOps engineer is mostly like a tooling expert, like the entire DevOps tool chain, CI, CD, everything. So my understanding was that a DevOps engineer is more of like a DevOps tool expert, and is not actually a core developer, neither a core tester nor a system admin.
See, as of now,
is that understanding correct?
No. As of now, the way it's going to work is, developers also will do a little bit of these activities, because developers, the way they prepare their development environment today. Let's say, I'm a new joinee joining your team. You are a developer. You are part of a team. You are a developer. Now I'm a fresher who is joining your team. Now, what typically you would do if you are my lead? Maybe you will send one email, Jagan, this is my this is our document, which this document will help you set up the development environment. Maybe if you are working in Java stack, maybe you may say, okay, install Eclipse, install this is the version control. We are using Git as the version control. Then you install this. You will write all the instructions to set up the development machine. As a fresher, it may take 1 or 2 days to actually successfully start setting up my development environment. Let's say if I'm using DevOps, probably what you could do, you can send me an email and say, Jagan, can you run this particular command, and your development environment will be ready, right?
Okay.
So I run the command and my development setup is already ready. And this, it is not typically required that I should raise a ticket for a system administration team to do, because developers are going to set up their development environment manually themselves, typically, just like they have been doing. But today, they are not going to, you cannot afford to do this manually, right? So when you have these DevOps kind of tools, you can automate that. So in that sense, now developers also will learn a little bit of system administration, right? And the infrastructure services that the system administration team they have been providing, they have been doing manually, that will be completely automated with these kind of scripts. So for instance, the tool that I showed, the script that I showed, right? The Docker file. This is the infrastructure as code, right? This is the infrastructure as code. So like this, you can write maybe Ansible script, right? You may write Ansible script. So for instance, you may, let me show if I have something. Right. So, okay, you have this, this is not a small, this is a small one. Maybe I can say install Tomcat on Ubuntu. Yeah, I have this YAML. This is a playbook. Yeah, this is a small playbook. Right. So this is the infrastructure as code.
Right.
And here, what we are trying to do, we are trying to install software. Typically, this is what a system administrator is going to do manually. But now
Yes.
the system
Right.
administrator has to write this as a code. Right.
Got it.
Yeah. So that's the difference. Yeah.
So automation. Mostly
Yes,
it is like automating everything.
Exactly.
Where everything was manual before.
Exactly.
That is what.
Right. So as soon as you check in your code, now it is going to prepare an image automatically, and the product will be the product. It is going to product code. It's going to take from the version control, and you're going to combine with the Jenkins, all that. And now it's going to test and give you feedback. Right. So that's when you become truly agile. Right.
Correct.
So the change could come from QA team, the change could come from system administration team, or the change could come from development team. Anyone who does that in a like a code, that is going to be tested automatically, and then it's going to give feedback. See, agile is all about fail fast, and how you do this is how exactly, right? Yeah. Okay, I think it's 12:15 now. Yeah, let's wrap it up today. And you can watch out for that meetup space, and I'll be posting when similar meetups. I mean, every week. That is the idea. This is the first one, and thanks for joining. Right, and spread this news, and feel free to share the. This is the URL, right? So this is the URL. You can share to your friends and colleagues if you think that they might be interested in DevOps, right? And yeah, so and then like you're also feel free to, I mean, you can also, you're also most welcome to present if you have some topics to share with this one, right? Yeah, thank you all.
Thank you, Jagan. Thank you.
Thank you.